Okay, hi guys. So we'll be continuing looking into the rate constant and forming the relationship between those and the RNS equations. So in the last lecture we saw that the rate constant of the overall complex reaction of NO plus O2 gives NO2 was AF divided by KB into K2. So we can write K as equals to A e to the power minus EA upon RT. We can write Kf as AF E minus EA upon RT. This is EA for forward direction, so this is EAF rather. EAF. Let me write it again. This would be minus EAF divided by RT. K2 would be equals to A2 times e to the power minus EA 2 upon RT, and KB would be equals to AB E EAB upon RT, and we already know that K is equals to KF K2 upon KB. So just putting the values of these rate constant into this term, so A would be equals to, what is KF? KF is nothing but AF EAF e to the power minus EAF upon RT. K2 is A2 e to the power minus EA2 upon RT, and KB is AB e to the power minus EAB upon RT. So we can write that K would be equals to AF times A2 upon AB times, let me write it down in the next line. So this would be equals to, K would be equals to AF times A2 divided by AB times e to the power minus EA F upon RT minus EA2 upon RT and plus EAB upon RT. Okay, and we can equate this K to A e to the power minus EA upon RT. So just forming an analogy or just comparing the terms here, so A is nothing but our pre-exponential factor of complex reaction, so that could be written as, so first K can be written as A e to the power minus EA upon RT. So when we compare K, we get to compare A with this term and E to the power minus E upon RT to this term. Hence we can write that the pre-exponential factor of the reaction would be AF times A2 upon AB, and EA similarly would be equals to EAF plus EA2 minus EAB, because this is also minus EA upon RT and this is also minus this, so minus and minus get cancelled and all the plus terms get converted into minus terms here, and all the minus terms get converted into positive terms here. So this is the activation energy of the complex reaction. Okay, next let us see the method 2, which is the steady state approximation method for the same reaction. So now we are seeing method 2, which is steady state approximation method. So suppose we have the equation like NO plus NO getting converted into N2O2. This is a rapid reversible reaction. We have already seen rapid reversible reaction with rate constant Kf and Kb in the forward and backward direction. This was our step 1, and step 2 would be this N2O2 reacting with O2 in K2 as the rate constant and forming NO2, which is a slow process. So steady state approximation method says that the concentration of N2O2, which is the intermediate, should not be changing, or d of N2O2 by dt should be equals to 0. So first let us see what is the formation or rate of appearance of NO2. So rate of appearance of NO2 can be written as K2 times N2O2. Why we are writing the order as 2 here, directly writing N2O2 and O2? Because this is a complex reaction. We have broken it into 2 elementary steps, and in elementary steps order of reaction is same as the molecularity of the reaction, hence order would be 2. And we know that N2O2 is a intermediate in this process. So we can write d of N2O2 by dt would be equals to Kf times NO2. Why we are writing this? Because this is the rate of appearance of N2O2 minus what is the rate of disappearance of N2O2, as this is the reversible step, so we should write Kb times concentration of N2O2 and minus this is also consumed in this reaction, so the rate of disappearance of N2O2 here would be K2 times N2O2 and O2. So this should be equal to 0 according to the steady state approximation method. So we should write that Kf times NO whole twice should be equals to Kb plus K2 and N2O2, concentration of N2O2 rather. Okay, so we can write from here that we already know that rate of the reaction is equals to K2 times N2O2 into O2. Okay, so rate can be written as, here we have already written K2 times concentration of N2O2 divided by concentration of O2, just putting the values here. So this would be equals to K2 times, what is the value of N2O2? N2O2 from this above equation can be written as Kf times NO square divided by Kb plus K2 multiplied with this O2. Okay, so this is, by the way, K2 of O2 also here, just not, this is K2 times O2 also here. Okay, this is like this. Yes, so this is the rate which we get from the steady state approximation method. So with this we come to the end of this lecture. In the next lecture we'll be seeing one more example on the same. So till then, good luck and goodbye.